if it got this, but we're going to try. I'm going to show you an example that is really easy. This line is y equal to negative 2x plus 4. And I want to know the area under the curve. We can do that with geometry, right? That's easy. This, if we go, this is 4. And to get this whole thing to equal 0, x would have to be 2, right? And so the area is equal to 1/2 base, which is 2, times height, which is 4, which means it's 4, right? Well, let's see what we can do if we can integrate this. Do we all agree if this is 2 and that's 0, this area, if we were doing integrals, would be the integral from 0 to 2. Is that my a and b? So my a equals 0 and my b equals 2 for that region. And what am I integrating? I'm integrating this height, which is that function right there. So I'm integrating negative 2x plus 4 dx. Okay, the dx stands for the delta x, way up here. That's the delta x. Notice that this is f of x, that's f of x, right there, and that's the delta x, it's the same thing. So can you tell me the antiderivative for negative 2x? Yeah, what is it? Negative x squared, because it's negative 2 over 2, right? What's the antiderivative of 4? 4x. Okay, I'm going to evaluate that from 0 to 2. And here's how you evaluate it. No, we'll get to that later. Right now I'm just showing this just for demonstration purposes. It's the first fundamental theorem of calculus. We'll get to why you don't do plus c later, okay? But for that, does that equal, I'm going to evaluate it. So the way this works, we're going to evaluate the b, we're going to plug it in, and we're going to subtract off the 0. So it's going to be, plugging in 2 is going to be negative 4, plugging in 2 plus 8, minus putting in 0 is at 0. Is that going to give me 4? It's the same answer. So the way it works for when you're doing a definite integral, so if I'm integrating, so if I want area, it's the integral from a to b of f of x dx. Do we all agree that the antiderivative of little f is capital F? Remember that notation? But it's going to be f of b minus capital F of a. So you get the antiderivative you evaluated at b, and you subtract the antiderivative evaluated at a. This is the first fundamental theorem of calculus. It's kind of important. It's the first one. There's a second. We'll get to it. It was really messy because I'm trying not to. I'm learning to use this one. That's the first fundamental theorem of calculus. So do you see that you can get area with geometry, you can get area with calculus? But for this example up here, we didn't want to do it with geometry. We want to do it with calculus. So ultimately, you're going to learn to do the Riemann sums for the approximations, and then if we have an infinite number of rectangles, we do definite integrals, which is antiderivatives and evaluating. That's our goal. Okay, so we're not going to get to that till tomorrow, maybe. I'll have to look on the calendar. The point right now is, now that we know that area is integrals, there are some properties you need to know. So that's our next step. I'm going to go to the next page, and this would be a great time to stop.